Welcome everyone. Thank you for joining SunWize Power and Batteries webinar series. My name is Amy Fong and I will be your moderator today. Today's webinar is a joint effort between SunWize Power and Battery and Morningstar. I have presenting today Mark Perry with SunWize Power and our Morningstar partners, Mark McHenry and Doug Grubbs. Everyone is currently in listen-only mode. If you do have a question as we go through our presentation, there is a question chat on the right side, default right side of your GoToWebinar panel. Go ahead and just type in those questions. We'll try to answer them as we go along, but if we don't get to it, we will have a Q&A, time permitting, at the very end. All right, let's get started. A quick overview of the agenda. We're going to do an introduction of the companies and then jump straight into what a solar charge controller is. And then we'll have Morningstar talk specifically about the differences between a PWM versus an MPPT controller, as well as some details about efficiency and oversizing. We'll finish by comparing several Morningstar products to each other and how to go about finding the right product you need. All right, Mark, let's get started with you with an intro of SunWize Power and Battery.
Sounds good. Thank you, everybody, for showing up today. I looked at some of the attendees and recognized quite a few names in there, so welcome. Appreciate you guys showing up. For those of you who don't know about SunWize Power and Battery, again, we're a very sort of nimble design company that also sells components. So we design a lot of off-grid stuff. We've been doing it for about 20 years. They typically are a standalone power system with assemblies for powering stuff that is definitely not near any sort of utility. We also have the ability to build out components that are in OEM style, where you have a what they call just a build out, which may have an enclosure and a power panel of some sort. We also do components as well. So let's head on over to the next slide, Amy. And this shows you kind of some of the components that we sell: batteries, side of pole mounts, charge controllers, inverters. Obviously Morningstar is in there as well. And so there's a large group of customers that also use this sort of component purchase for their own OEM installation of their own sort of manufactured items. So we support that side as well. If you head back up to the previous slide, Amy, I think I passed up real quick. So the Power Ready system is our engineered smaller system. Typically you can go up to, around 150 watts, 200 watts continuous. The Power Station is a very large system, and that can be anywhere in the thousands of watts category. And we can do some hybrid solutions there, where we use either some sort of gas generator of some sort to sort of offset to keep that array size in line. The Power Online is essentially a backup system that is driven by utilities powering batteries, and then obviously components, which we covered. So we can go ahead and head back down and move on to the next slide. So who is Morningstar? Guys from Morningstar, let's have a chat.
Okay, great. Thanks for having us. This is Mark McHenry, and I'm here with Doug Grubbs. So we're just going to say a few words about Morningstar. For over 20 years, we've been a leading manufacturer of solar charge controllers and inverters, and we've had the same ownership and management and distribution partners since the very beginning. Known for our high-quality products, our customers gave us an A rating for product quality in this year's annual customer survey, and we have over 2.5 million Morningstar products that have been supplied worldwide since our inception. And our products, as you can see here on this slide, are designed in the U.S., and we have warehouses in Los Angeles and Taiwan, and we have numerous patents and trademarks. So that's kind of Morningstar in a nutshell. And we've been partnering with SunWize for well over a decade now, and in addition to assistance with distribution, SunWize has been very helpful over the years with providing technical support, helping put together a complete solar installation involving modules, batteries, from other manufacturers, integrating them with our controllers and other components.
and we can't emphasize enough the partnership that has kind of grown between SunWize, Power, and Morningstar. Our engineers speak with their engineers very frequently to sort of root out issues that might be coming up that are complications within design. We have all of their technical specifications built into our sizing systems, so we know exactly how well these things work with the other components of industrial design systems. They've got a wonderful group of people, as well as a great product and a warranty that is surpassed by not a lot out there. So we stand by them, they stand by us, and it's been a great relationship. And in fact, I think it's been a little bit longer than a decade that we've been working together.
Wow, that's really great. Thanks for the introduction. As a reminder, if you guys have questions, do put them over on the question panel. I've already got one. It's a great question, but we'll get to that a little bit later, because let's get into our meat of our conversation here. What does a solar charge controller do? Morningstar, we'll go into that.
Okay, thanks. The slide is up. Everyone can see that. So a charge controller in a PV system maintains a battery at its highest stated charge while it's protecting the battery from overcharge by the array. And some controllers also might include load control with low voltage disconnect, and this prevents over discharge the battery from system loads. And this also maximizes availability, or I should say available battery capacity and cycle life. Lighting control options are also available with some controllers, and some of these devices can also provide system status indicators with meters and LEDs to display metrics like battery voltages, current, system operating temperatures, and alerts. And some controllers can facilitate remote communications with power systems. And as you can see from this slide, the charge controller generally represents about 10% of your total system costs, but a failed controller can cause complete failure in your entire solar system. So you definitely don't want to try to cut corners on the 10% that the rest of your system relies on. At a minimum, you could have loss of power, damaged batteries could result from failed controller, and you can have the best batteries and best modules in the world, but they're only as reliable as your controller is.
Yeah, and the one thing I would just add to that is that in a lot of these sort of remote applications, as you can see in this one deployment, I believe that's not, I don't know exactly where that one, Amy, where is that one? Do you know offhand?
No, I don't know offhand.
Yeah. Anyway, the long and short of it is that you've got this very remote scenario. To get up there, my guess is it's not terribly convenient. So what we often do is build in redundancies with various packages of multiple controllers. Even though it is a Morningstar, we want to make sure that we build in the redundancy that can keep these things up and running. So and frankly, I think the Morningstar products will keep you guys up and running without incident. So in off-grid applications, there's a lot of different applications and areas in which we focus. Telecom obviously is a big one where we have to use some larger charge controllers, but they need to not interfere with telecom equipment. Gas and oil is one of those where you've got to have some pretty durable products out there in the field. Obviously, lighting is a controller-based scenario that we also do. Traffic and transportation, again, these things have to be fairly durable. In railroad signaling, again, that's another durable scenario, and in security instrumentation, those have to be absolutely reliable because of the fact that they're highly needed in security and highly coveted that they work. So these are the top applications that the Morningstar controllers are used for, at least by SunWize. So if we click on the next slide, we'll go into the sort of the stages in which they're used. Now, I can talk to this slide if you'd like, but I think this, since Mark and Doug, your controllers do this, why don't you go ahead and just review this.
Okay, sure, thanks. So what you see in this illustration here, it's just kind of walking you through how batteries are charged by our controllers. And as you can see on this chart, since there's no PV to charge batteries at night, before morning, the batteries are typically at their lowest state of charge. And then when daylight breaks, bulk charging or normal charging begins. And bulk charging is a high charge rate that charges the battery up to a voltage, resulting in a state of charge of about 80 to 90%. And at this point, when the battery is nearly fully charged, most of the battery's active material has been converted to its original form, and then current regulations require to limit the amount of overcharge supplied to the battery. So for the next 1 to 3 hours, you can see on this chart here, the battery goes through absorption charging, whereby charge current is reduced to maintain the battery voltage at a certain regulation voltage. And when absorption charging is complete, the battery is at that point at about 98% state of charge. And at around 98% state of charge, the charging voltage is lowered slightly to the float voltage, and the charging current is set to a very low rate, as you can see here on the chart. So this stage, again, is called float, or sometimes people say trickle charging to finish the battery charging. Float charge rate must be less than the self-discharge rate, or the battery is going to be overcharged. So for flooded open vent batteries, an equalization charge is used about once a week. You can see that at kind of the top of the chart there. It's usually done about once a week or once a month to maintain consistent specific gravities among individual battery cells. And the more deeply a battery is discharged on a daily basis, the more often equalization charging is required. And again, this is for flooded open vent batteries, not sealed or valve regulated batteries, because they can be damaged by equalization. So now that we've kind of gone through this chart and taken a general overview on charge controllers and the battery charging states, I'm going to highlight some of the common characteristics that pertain to Morningstar controllers, and I think we have the slide up there now. So let's just walk through this a little. So you see here that all Morningstar controllers have a 5-year warranty, but we've had many examples of our controllers lasting 15 years or more in some pretty harsh climates. Our manufacturing facility is ISO 9001 certified, and as some of you might know, Morningstar controllers are passively cooled, so they have no fans or moving parts. That can be a point of failure. And this is a very important point, and I can share a quick example that I think most people can relate to. If you've ever looked inside your computer at the cooling fan, if you've done this, chances are you've seen all types of dust and debris, fans thrown in, and that's not good for a computer, and likewise it's not good for a charge controller, especially a controller that you want to last for 5 years or more. And if the fan or other cooling part breaks or slows down, as they sometimes do, the controller would get hotter, and that's bad for electrical components. And this can ultimately shorten the life of the controller and also decrease its efficiency. Another point I should say about fans, they can often produce unwanted and very disturbing noise, and this can be problematic depending on the application. Also, our devices have lightning and transient surge protection, as you can see here. This offers a degree of protection from nearby lightning, and this protection won't degrade over time. It has a faster response time than MOVs, but if you want protection against larger surges, you might want to install an MOV externally. And regarding operating temperatures, our controllers perform well through a wide range of temperatures, from Arctic temperatures that are well below freezing to desert climates that are well above room temperature. Morningstar is very easy to integrate with other components of a solar installation, including almost all types and brands of modules, batteries, inverters, and other balance of system components. and Morningstar controllers are easy to operate and maintain. Our customers often say you can basically just set it and forget it. So there's no need to set up IV curve sweep times. Our devices have a small footprint. They're lightweight for their capacity. Firmware can be updated in the field on site in a few minutes. We have controllers that are compliant with FCC regulations to ensure that there's no noise interference caused by the controller. And in terms of scalability, our controllers can be connected in parallel without using communications link, since we have very accurate voltage regulation and voltage sensing. And the last bullet that you see on this slide, environmental protections associated with Morningstar controllers include epoxy encapsulation and conformal coating. And I'm going to show you some pictures of these protections on the next slide. So if we can go ahead and...
Right before we do that, I do have a question from Nick about what's the typical lifespan of one of these charge controllers beyond that 5-year warranty?
Okay, so I think, I mean, we've had, like I said, a lot of people have commented that they've had our controllers for 15 years or more. You know, but our warranty is 5 years. But yeah, clearly we do get a lot of times people say, you know, they've had it for 10 years, 15 years, or in some cases even longer.
All right, thank
you. They're designed with an expected life expectancy of 15 years, but their warranty is 5 years.
Thanks for that question. All right, moving right along.
Okay, well, thanks very much. Looks like we have the slide up about the epoxy encapsulation. So just to illustrate a point about this, I'm going to use an example. What you're looking at here is our SunSaver Controller. And in this picture, what you see right now, the cover is on the controller. But now if we can just fast forward, I'm going to show you a picture of the controller with the cover off. And so there you can see the epoxy underneath it. This epoxy protection is like a hard plastic that completely covers and isolates all the electrical components on the PC board. And this protects against humidity and airborne particles, and it's a best practice for electrical device manufacturing. So many controller brands don't have this protection, so this is an important consideration when you're evaluating a charge controller. And then regarding conformal coating, coating is applied by a spray that goes over the circuit boards, and this protects against dampness and corrosion. So you see in this picture, you can see the nozzle there kind of center up top. Yeah, there you go. And this nozzle here is spraying a fine mist of epoxy or silicone coating. And this spray is almost invisible, so I just kind of made a graphical embellishment here so you can see it. This nozzle is going to travel up and down and across this whole circuit board to coat the entire board to apply a coating that will provide additional protection against moisture, dust, and other contaminants. And we also use surface mount components that are precisely assembled by machine, not hand assembly. So this makes for a very reliable, high quality product. And now that we've kind of gone over the environmental protections, let's move ahead and talk about the different types of controllers that we manufacture. And for this, I'm going to actually hand over to Doug Grubbs, our applications engineer. So, Doug, if you're able, go ahead.
Okay. This chart shows the 2 different types of controllers that Morningstar manufactures. The original controller that we started with is the PWM controller, or pulse width modulation. It's an on-off switch. It's a series switch that does pulse width modulation, very high frequency, or not very high frequency, but higher frequency switching that regulates the voltage. And so the array actually operates at the battery voltage. MPPT controllers, on their other hand, convert from the maximum power voltage down to battery voltage and converts that higher voltage to higher current on the output. So generally PWM controllers are designed with a VMP about 1.5 times the nominal voltage of the battery. So if you had a battery of 12 volts, the VMP for the array would typically be about 17 or 18 volts. That way you always have voltage there that's available and powered so it can charge the batteries. And MPPT controllers can operate with higher VM voltages, and it will continue to operate at that higher voltage and take that high voltage and go to the lower voltage with a higher output current. So some people have referred to this as MPPT boost. It's not really boosting the available power, it's just operating at the maximum power. So you get a little boost over what you would with PWM. So PWM controllers are typically good with smaller module configurations and lower voltages, and MPPT controllers do better with larger systems because you get more of that MPPT boost that makes it more cost effective. With the smaller controllers, it's just not always feasible to use the MPPT unless you're going from a higher voltage array to a lower voltage to get the voltage to operate at a higher voltage on the array. So you can use different types of modules, and you have a lot more choices with MPPT controllers. So PWM controllers are also used a lot in warmer climates where the MPPT boost won't be as effective. This is because in hotter conditions, the array voltage is reduced closer to the battery voltage, and you just don't have that much of a boost in some cases. With MPPT controllers, you get more boost in the colder days and when the battery voltage is low. And that's when you really need the power, so it's a really nice added boost when you really need that extra power. So the MPPT can be really effective in those systems that need it. And in the next slide, we'll talk a little bit, show the IV curve. So this is a current versus voltage versus current graph showing the typical 12-volt nominal PV module. And you can see where the PWM operates in the lower voltage range. And if you look on the right side, the power is lower than where it is at maximum power point. So you can see that the maximum power point tracker will operate at a higher power level than the controller within a PWM will. But it may not always be worth the added cost if it's a smaller system or if it's a lower voltage. So one of the important factors with this power boost is that the efficiency, which we'll show on the next graph, on the next slide. So this shows the difference between one of our competitors' MPPT controllers and ours, and you can see how our efficiency is good at all power levels pretty much, at very low power levels and at very high power levels. Whereas you might only have a difference of 1% on the peak efficiency. You might say, well, it's only 1% less. I mean, we got a 99% efficiency versus a 98% efficiency. But at that max power, you're really losing a lot of efficiency. And in those cases, a lot of these MPPT controllers use fans, which use power to come on and cool the controller because it's running so hot. All that efficiency loss is dissipated as heat inside the controller and can really affect the reliability of the controller. And you also see how our controller a lot of times will come on earlier in the day, in the morning, and will operate with higher efficiency at low power levels. And that means on cloudy days you could get a lot more efficiency in those low sunlight periods. And to summarize on the next slide, The efficiency that our controllers offer is through the low, medium, and high output power levels, and a small difference in efficiency could be a good deal of power in the high power range, exceeding the max efficiency rating of the controller. So to conclude on the next slide, what you get would be with more charging power, more boost, so you can take advantage of that boost power, increased energy harvest throughout the day, higher efficiency throughout the power range. The controller runs cooler because it's not dissipating energy as heat with the power loss. In addition, we have a TrakStar maximum power point tracking, which can sweep the entire array in less than a second and find the exact power point and stay on track all day long. So it's we've seen some systems that have been replaced with our controller and are operating at over 10% in some cases because the other one just wasn't tracking very well. And then the other part is because you could probably expect 2 to 7% in most cases, but for some controllers that don't track very well, it really makes a big difference to be on the right power point of the array.
Great.
And so,
before we move on to oversizing, I have a question from Steve regarding the MPPT controller. He's asking if it compensates for panel temperature to serve the VMP to achieve this efficiency.
Excuse me?
Do the MPPT controllers compensate for panel temperature to serve to VMP in order to achieve this efficiency? I'm sorry if I mangled up the question, but that's what I'm seeing.
Yes. The temperature will have effect on where it will track. So if it changes during the day because of heat or coldness, it will go to wherever that maximum power point is on the array at that time of the day. It won't just set a MPPT setting for the day or operate at a percentage of VOC or something. That can be really inaccurate and not give you the exact power point. Also, all our controllers, I don't know if Mark mentioned this, have temperature compensation for the batteries. So the batteries need a different voltage setting depending on temperature, and we offer temperature compensation for all of our controllers.
Great answer. Thank you.
And so on the next slide, we are looking a little bit about the power, how to match the power to the MPPT controllers. And a lot of times it comes up, well, can I oversize, what if I have a 240 volt module for your 240 watt module for the 200 watt nominal SunSaver with a 12 volt system. And there's no problem with doing this. It won't damage the controller. You can even oversize it more than this. And the controller will limit the output current to the 100% rated current without exceeding the limit, so you won't damage or have any breakers trip if you do oversize it. That we've heard that reported with some MPPT controllers that if you oversize them, they'll trip the battery breaker. And then and so our controllers are designed with the power saving, so you don't have to worry about a little bit of oversizing. And actually, a lot of these modules won't even operate at 100% state of the rating of the module. Depending on temperature conditions, the location, the tilt, and other factors, you may never even see the full 40 volts from the module. And on the next slide, we'll show how the power shaving works. So this would be a 240 input, and the output from a larger MPPT controller, you can see would be on the top curve. With the SunSaver MPPT 15, you'll see it shaving the power. It's rated for 200. It could vary based on the battery voltage, but if it is limiting it to 200 watts, you'll lose some of the power. But it's not, as you can see, it's more. You still get more than you would with the 200-watt module. And in the morning and evening, you don't lose anything. And in this diagram, actually, you get 2/3 of the extra power is harvested, while that top red part is about 1/3 of the extra power that you lose. So you still get a good percentage of the power with the lower. So oversizing is okay. And then on cloudy days, or this is an intermittent day, you see that in the blue is the 240-watt module. And the black is 200-watt module. This is taken from actual data from a solar PV system and scaled. And so you can see the difference where it would start power shaving, and very, very little, like maybe 1%, I think, in this example, would be lost on that day. So on the next slide, we'll go over our controllers. Here's our line of PWM controllers. Starting from the left, we have the TriStar Controller, which is our highest rated controller. It's rated, and it has 3 functions, and can be used for charging, load control, and diversion control. We'll talk about a little bit more about that later. The ProStar is a mid-ranged controller. We just lost the screen there for a second. I got it here. And then we show the remote. Oh, I'm sorry. I lost the page. We lost power, I think.
Oops.
I can still continue though. Somehow the computer's off, but we still have the telephone on. So we'll just continue. I'll go with my PC here, my laptop. With the TriStar, the ProStar, and then the SunSaver is a nice small controller, especially for oil and gas. The SunSaver Duo can operate with a single array with 2 battery banks. And then the SureSign is a simple lighting. I mean, the Sunlight is a simple lighting controller with preset configurations for evening and morning settings and dusk till dawn. The Sunkeeper is an outdoor rated controller that can fit into the junction box on the back of a module. So it's rated for very high temperatures. The sun guards also can be used outside. If you look inside there, it's all epoxy encapsulated inside. And all these controllers, as I mentioned, have temperature compensation. The reliability is engineered into all these products, so you can count on it, so you don't have to go to the site with problems, at least as little as possible. We have very many long-term customers that are still use our products after years because they know the reliability of our products, and they won't have to be having to go to the site, which would cost a lot more than the cost of the controllers for each visit in some cases. So on the next slide, we'll talk a little bit about the SunSaver. This is ideal for telecom, oil and gas applications, smaller systems. It's rated for 6 amps, 10 amps, and 20 amps. We have versions that are for 12 volts and versions that are for 24 volts. So you want to make sure you get the right voltage. These are certified for use in hazardous locations, Class 1, Division 2, groups A, B, C, and D. This is often used in oil and gas for that reason. It's very reliable. People have told me, so especially SunWize has talked about how much longer the batteries can last with our controllers. with the SunSaver because it just charges the battery how it's supposed to be charged, and it's very accurate. It has environmental protection, epoxy encapsulation, and marine rated terminals. And so I think Mark's going to show you an oil and gas application.
Yeah, so we were just looking at the the SunSaver, and again with the C1D2 rating, we use them frequently in the gas and oil industry, and this is a good example of one that was 20 miles away from utility power. And in other words, to try to get utility out to this, you're surrounded by oil, but none of it's usable, none of it's generating electricity. It may have cost $100,000, $200,000 to get, to go those 20 miles. Here you've got a simple solution. It's a, it's a small power ready system that was, in an unattended remote site that, needed to be out there for a long period of time. And again, with the, the SunSaver being one of the more durable products that, are out there in these kind of environments, charging a system properly and having the right balance between, the charge controller and the battery bank, can really make or break a system. In these desert environments, you've got heat issues, you've got the fact that it needs to be reliable, it needs to go up quickly because these guys need to move around and do other things. So we design these systems to be out in the field with batteries lasting hopefully somewhere in the neck of the neighborhood of 7 to 10 years. This is a PR140, so it's a single 140 module. It comes pre-assembled, meaning that the array is mounted to the racking system. The power boxes, that have the PRCP inside, that's all pre-wired and ready to roll. So this thing will show up in a crate. The only thing that you'll do in the field is make sure you've got a pole that's already set and ready to roll. And this thing will install with 1 or 2 guys in an hour and a half, 2 hours. With a full commissioning guideline. So very important for the gas and oil industry because they need to be able to communicate with radios, may need valve controls, gas flow, injection, a lot of different applications out in the gas and oil fields.
One other thing I want to add was that the SunSaver is rated to 60 degrees Celsius at the full power, full current rate. So that's another advantage for these very hot environments. I just noticed the desert. It looks like a very warm environment there. So they can really last and take that heat really well. So no problem with that. So on the next slide, we have the TriStar Controller. This supports solar charging, load control, and diversion control for wind and hydro. It operates at the full power rating to 45 degrees Celsius. That's a 45 amp output or 60 amps with 12 to 48 volts DC. It can be set for the voltage or it can be automatically detect the voltage. There's simple dip switch presets available, so it's plug and play, or you can go in with a PC connection. We offer that with an Ethernet on the 60 amp or a serial connection on both, for all of the, well, I'm sorry, this is the TriStar, not the TriStar MPPT. So this has a RS-232 serial connection, and you can connect to a PC to program it with custom settings if you want. You can also set up data logging and remote monitoring. And with these larger controllers, this is the largest one we have with the PWM, and you really get the, it's really cost effective at this power range to use this with larger systems. This has extensive electronic protections, no fans, and it's passively cooled. And those fins, I mean, they actually stay rather cool. They don't heat up like really excessively like some products do.
So it's, excuse me, is this a controller that you would say can support the dual input? So like if you have power coming from a solar panel as well as like a generator?
Well, a generator, if you have a DC generator, it wouldn't be compatible with a DC generator, but you can use another of our products called the relay driver with a DC generator, typically, which would turn it on and off the generator based on voltage. Another possibility with the wind, or I guess a generator could do this too, but generally we'll see it with wind, is that you'll set this up in diversion and using diodes to protect the circuits of the solar and wind. You could have this operating for both the solar and wind at the same time. So we've seen that done, all these applications. We have wiring diagrams on our website, and I'm sure SunWize would be able to help you configure it.
Yeah, definitely. I hope that answers your question, Solomon.
So there's a lot of ways to configure hybrid solar wind systems, and so we have a lot of documentation on how to configure that on our website. And we can also, if you have any other questions that seem like the documents aren't helping you, you can always contact us and ask us about that. So here's an application using the TriStar with telecom.
Yeah, this was actually a telecom repeater site out in the Mojave Desert, and it was originally run off of a very large generator, and they were having to bring diesel out to this thing, very frequently. I think it was bi-weekly, if not every 3 weeks, just to keep the thing going. So the main focus here was to reduce the generator runtime, get some reliable power out there, and essentially get this thing sort of off that, that busy schedule of dragging a tanker out there and filling a 2,000-gallon tank every so often. So what we did here was designed a fairly interesting system which acts as a canopy. If you look at it, those sonnet tubes are up about 8 feet, and then that's when the array base is tucked in there, and then the array goes on top, and it was used for shading and temperatures out in the Mojave Desert. So there was a reason for doing that. Obviously they need reliable power, so with that relay, there was still a generator out there, but what we did was we used the TriStar and the relay driver to limit the amount of time that generator was running. So when the batteries, they would operate for about 4 to 5 days, and then the voltage on the battery bank would go to the point where the relay driver would kick on the generator, and 6 hours later that battery bank would be completely full. And so it would cycle the system through this battery voltage need, and thus reducing the amount of time that the generator is running. Now what that'll also do is it reduces your fuel consumption, certainly, but it also reduces the wear and tear on a generator. As we all know, they have moving parts, and they'll wear out a lot faster than solid state stuff like a solar system. So it was a relatively interesting installation. We had a 7,680 watt array with a pre-engineered hybrid system that essentially used their existing generator, so they didn't have to buy any new generator. So this was just a way to keep them, in a very solid state out in the middle of the Mojave Desert, keeping the cell phone conversations going.
So here's shows our MPPT controllers. The TriStar MPPT is in the center. That's 150 volt maximum input voltage. On the left side, you see the 600 volt version of the TriStar MPPT, and then the SunSaver MPPT on the right, which is the 15 amp controller for 12 and 24 volt systems. So the SunSaver MPPT controller was our first MPPT controller. It's got a very small footprint, and like I said, it's 15 amps, 12 volts, 24 volt systems. It provides a charging boost to over what a regular SunSaver would operate with. Has the flexibility so you can use like a 60 cell module which has a VMP of 30 volts, which you really can't use with PWM controller. And some of these modules can be more cost effective to use the different modules. It also reduces the power, the wire run sizing. You can also, if you are working with a 12 volt nominal, you can put strings of modules and run at higher voltage levels and reduce the number of combined circuits in the array. So it really has a lot of value in that respect too. So the peak efficiency of this is 97.5%. And on the next slide, we have the TriStar MPPT controller, and this is available in 30 amps, 45 amps, and 50 amps for 12 to 48 volt DC systems. And the PV input is up to 150 volts maximum VOC. That's on the coldest temperatures. The peak efficiency is 99%. We were showing you the graphs of the efficiency earlier. It has extensive networking and communications capabilities. This includes, on the 60 amp version, it includes an Ethernet port in addition to the serial ports which are available on all of these. It also has a meter port, and you can attach the TriStar meter to either the TriStar MPPT or the TriStar, and you can monitor or you can show the data logging and the real-time view of the functioning of the system. It has lightning and transient surge protection, and it has built-in protections with electronic resets. We don't use fuses in any of our electronic protections. They automatically reset as if you get like a over voltage or over current. When the system changes, it should automatically start working again instead of having to go to the site. So that's another feature that's good to have. So the next slide, we have the 600 volt, which is basically a 600 volt version of the TriStar MPPT. You can go with much higher voltages. That means you can have a single string in some cases so you don't have to have any combiner or no fuses in some cases on the array side. This has a peak efficiency of 97.9%, even though it has this very high voltage and you're transforming down almost 10 times lower voltages, it still has this very high efficiency. It's preset for 48 volts, and you could also set it for 24 and 36 volts. It does a full IV curve sweep very quickly. It tracks just as well as the regular TriStar MPPT. We're also getting ready to introduce the parallel input, so you can combine at the array and come in with a single wire, and then decombine at the controllers and operate in parallel on the inputs. And this is like the first time this has been done in the industry. So we have test systems operating now, and so that should be available in the near future. This also has extensive networking and communications capabilities. One place you might see this is like in a mountain situation where your array may be down in below and far away from the PV array, so you have to put the array far away from the location of the controller and the battery. So there just may not be enough sun in that location, so you can really put some long distance wire runs, operate at 300 or 400 volts, and still use a small wire to connect that, and it can be really cost effective. And so on the next slide, we have the the applications for our controllers. So this is a generally shows what applications are used for which controllers. There's no reason you couldn't use it for any of these applications, but this has just been a general trend that we and SunWize have seen. So as you see, there's many places that our controllers can be used in all these different applications. Some are very good with, like the SunSaver Duo especially is good for mobile applications, while the TriStar is really nice because it has a little built-in meter and it's real simple, and people really like having that meter that you can refer to very quickly. So there's a lot of different features that you'll see that make a difference for different applications. So at this point, I think that's the last slide. Oh yeah, we also have an accessories that go with our products. We offer ground fault protection. We have several meters and meter devices, remote temperature sensor. Some of our controllers, like the TriStar, won't do temperature compensation without the remote temperature sensor. You can also have the option of adding the temperature sensor instead of having it on the controller for better sensing of the battery temperature. The relieve driver, which we discussed, which you can use for driving up to 4 relays with logic capability. And then our DIN rails for mounting our devices and our communications adapter. And with that, I turn it back over to Amy for the SunWize Connect information.
Yeah, definitely. That was a great overview of all of Morningstar related products. But as Mark mentioned before as well, we have a lot of off-grid components that you can look at. The best way to see that is on our e-commerce portal, SunWize Connect, where you can view all those products, see their specifications and availability, even place orders online. You can, if you have an account, you can also access your order history, open invoices, and see tracking information that way. So if you haven't been on SunWize Connect, I really encourage you to go and check it out. And just to give you a little taste of it, this is kind of the filtering capabilities. So specifically looking at these charge controllers, if you wanted an MPPT versus a PWM, you have filters that you can narrow down your search. And then you can just go into, I just want to look at MPPT accessories or something of that nature. So we have a really built-in portal for you to browse all the products that we have available here. Besides all the components, we do specialize in creating these systems, and I'm going to have Mark kind of just talk a little bit about SunWize Power Systems.
Yeah, shameless plug for the system side of things.
Of course.
Well, you noted that you can go through and do the SunWize Connect thing and buy your parts and pieces and make one of these things yourself. It can be done. It's not a problem. But there are about 200 different parts and pieces that are actually in this system. So what a lot of folks will do is, instead of having, they're more of a sales-driven company where they're out there selling solutions, power to, power some sort of product that is out there for your client. And instead of being a manufacturer of these systems, they rely on us to actually put these together based on the overall amount of power that's used, where the thing is going to be located, how much, how many hours a day is this thing going to be on. So we determine those few things, and then we can build these for you, whether it's on a small, medium, large A-frame, a ground mount, a multiple arrays, single arrays, and, separated battery boxes. The customization is limitless on what is required at the site. For this example, you can see you've got quite a few guys here, which looks like about 6 or so guys. But in general, a power station of this nature, you could probably put up with 3 guys, 3 days, and one of the guys being electromechanical, the other 2 being mechanical. You may want to have a few extra guys around. It's up to you, but frankly, it isn't a very difficult thing to do. Everything, as you can see, those large arrays that are hanging from that forklift, that was all in one box, and actually it was probably split in half. So there was probably there was probably 5 or 6 sub-arrays in one large crate. You take them out, you batten them together, and then you assemble the A-frame, and then you, sort of like Lincoln Logs, you put these things together modularly. And again, 3 days, 3 guys to put in a system like this. So again, we encourage you guys to use the solar sizing worksheet. This is a brand new worksheet that we just came up with. It's a little cleaner than the previous one, for those of you who have submitted these before. But essentially what we need to know is, where is this thing going to go? So where's the location? What is the length of time this thing is going to be going? I mean, how many hours a day is the actual load going to be running? And then what is the load, what's the size of the load? Is it AC or DC? And, so we just need to know those few things. And from that, we can run behind the scenes a bunch of other proprietary software and sizing tools to come up with a solution for, the end customer and the dealer that's dealing with that end customer. One of the things to remember is that days of autonomy, it's not necessarily how many hours a day is this thing going to be available if the sun disappears. Days of autonomy has to do with a balance between the array, the battery bank, the charge controller. So it's this symphony of information going back and forth, which essentially, if sized properly, and again, most of the sizing that we do is based on, being a remote, unattended site, is that you really don't want to have to go out to this site, but maybe once a year to just double check, make sure everything is looking good. Or as you can see, this thing is in a protected area, so my guess is they come out once a year. But it's to also mitigate the amount of battery replacements you're going to need for the life of the system being out there. Properly sized, you can get, I just replaced a large system for a telecom company. This system had been out in the field for 10 years, and that's phenomenal for battery life and controller life and everything else. And the system was still running fairly well. If they ran into 3 days of kind of overcast, it would sputter, but that would be purely a battery replacement scenario. So the idea is size the thing properly to keep this thing out there in the field, as long as possible without having to do the replacement on the battery side.
Great, thanks. To answer your question, Daniel, does SunWize still carry SunWize brand panels? Yes, we do. And if you go to this link right here, sunwizepower.com, resources and downloads, you'll see the data sheets. You can see what's available, as well as SunWize Connect. You can browse it there too.
Yeah. And now we have at sunwizepower.com resources, there is most all of our data sheets with those modules, and then our rack systems, spreadsheets to figure out which module goes with which rack. So we're kind of making it a little bit easier on everybody by including that into the data sheets.
Yep, and on SunWize Connect, we're uploading Morningstar data sheets directly with those products. So if you're looking at something, you can download the data sheet directly from there too. So that wraps up our presentation. We do have a few questions that we can cover, but that's it for slides. This is contact information. If you're looking for Morningstar related technical questions, you have Mark and Doug's information. And then any system questions, of course, you can contact Mark Perry right here. Okay, let's go through these questions. Regarding oversizing controllers, I have a question about, we talked about oversizing based on current. What about input voltages or voltage input? One of those.
Okay. One of the things I was thinking about was that the PWM controllers, you can't oversize a PWM controller. That current limit, you shouldn't overdo that, and you can overcurrent the thing, and it could go into faults if nothing else, if it doesn't damage the controller. So the main thing with the oversizing would be the power. So there's no real input current limit per se. We have designated a maximum input of rated to the maximum output rating, but I've been told that that can be exceeded, but for now I would still go by the manual. In the manual it says not to exceed the input current limit, but you can you can never exceed the input voltage limit. So that's not permitted and would not be covered by the warranty if you exceeded the input voltage limit. So that shouldn't be done. That shouldn't happen if you sized it correctly. You can calculate the coolest record day, and the voltage should never go above that voltage if you've calculated it correctly. We have a sizing calculator which will show you the maximum sizes of the array, the maximum voltages, and then you can size it that way, or you can talk to Mark about sizing your system. And so there's no problem with the overvolt power.
I have a question from Ray asking about which controller is best for VHF low band, which is most vulnerable to noise. He comments that the TS45 and PS30M do cause noise on these radio systems.
Okay, so that's PWM noise. That's a switching noise. We have some information regarding this using twisted pairs of conductors and doing really good grounding, shortening the conductors as much as you can to the battery, and so there's only so much you can do. So in some cases, we do have several of our controllers have a telecom mode, which we don't recommend doing this in general because it slows down the PWM circuitry. So it's more like an on-off switching. It's slower, so it still operates fine, but it's just not quite as effective as the higher speed, higher frequency PWM. But it would slow it down to 1 hertz switching, which should still charge the batteries and not make any noise at all if you need that to use that feature.
Okay. Is the SHS-10 available without LVD?
The SHS, as far as I know, it's not available in the U.S. It's available with only an LVD that comes with it. If you don't need the LVD, you can simply bypass it. You can connect an inverter or whatever you have as a load directly to the battery if you don't want to use the LVD on the SHS controller or any of our controllers that don't have low voltage disconnect. We also sell SunSavers with and without LVD. So if you get a SunSaver with LVD, you can have some loads that you may not want to have ever disconnect. If they're really small, that might be an option, and you know that it wouldn't cause harm to the battery. And then you could have the larger loads on the LVD, possibly, that kind of situation.
All right, we're about a few minutes over now. Last question. How close does a battery need to be to the controller for proper temperature sensing?
Well, if it's not in the same room, if it's not going to be at the same temperature, if it's not in the same area, and you might have a battery inside of a building and the controller's outside, you definitely want to use the remote temperature sensor. Not all of our controllers have that possibility. The SunSaver, you should have it at the same temperature within 5 degrees or so of the battery for proper temperature compensation. So as long as it's in the same temperature range environment, it should be okay.
Yeah, and for instance, on our systems that I showed you there, typically the batteries, like an F1 or F2 enclosure, the batteries are at the base and the charge controller is mounted on a backplate, so it's within the same range. One thing I did want to mention is that I think we passed right by it with just a quick mention, but the string sizing calculator that Morningstar has on their website is fantastic. So if you guys have not used it, I highly suggest going there and tinkering with it. It's very self-explanatory, and it has helped me and my team on just sort of the quick, are we pushing the limits or not, sort of verification. So we use it ourselves, and I encourage you guys to use it. It's at morningstarcorp.com/string-calculator. So you may want to go just check it out. It's very helpful.
All right. Thanks, everyone, for sticking around and for coming to our webinar. Look forward to seeing you for upcoming webinars. If there's any remaining questions, the contact information is there. We will be sending out slides, and we'll reach out if there's any other things that need to be answered. Thank you.
Thank you.
Thank you.
Mark, Doug, thank you much. I appreciate it, and everybody else that attended. If you have questions, please feel free to reach out to us.